Okay, so today we're going to look at domain and range. Domain is your x values, and range is your y values. Depending on whether or not your data is discrete or if it's continuous will depend on how you write your domain and range. And so we'll start off looking at discrete, where all we have to do is to list our x and y values. And then we'll take a look at some continuous, where we will have to write them with inequalities. So first, looking at a set of points, this is discrete, and we'll have in each of these points our x and our y coordinate. So all we have to do is to list them out. And when we list them, they will typically list them in numerical order. And so we have 3, 5, 4, and then 3 again. We don't need to put the second 3, but we'll just put this in 3, 4, and 5. So that will be our domain. And then our range will be our y's. So our y's are -2, 1, 0, and 1. So once again, we won't need this to put the 1 twice. So we'll put -2, and then 0, and 1. And so all we had to do there was to list what our x's were and our y's. Same thing right here. This is a table. This is discrete data. So our x's will be on the left and our y's will be on the right. So we'll have our x's are 1, 2, 3, 4. So 1, 2, 3, 4. And then our y's are 50, 100, 150, and 200. Okay, so all you have to do is list it out. So when you have discrete data, it is pretty easy on a lot of it. There is one that's a little bit tougher. Here we have discrete data again, and so all we have to do is to list it out. So we have our x's. I keep making these marks right here. So our x's are 1, 6, and 24. And then our y's are 2, 7, 8, and 25. So 2, 7, 8, and 25. So, like I said, anytime you're doing discrete data, all you have to do is to list it out. Well, this is continuous. So whenever you have a continuous line, then we have to do our domain and range with compound inequalities. And so we'll start off with domain, our x, and then we'll put a less than symbol on either side. Well, with domain, we're talking how far to the left does it go, and we're looking at the x-axis. So we always have to go to our x-axis. So the furthest to the left would be -6. If the dot is filled in, then we have an equal to bar. And then over here to the right, the furthest we go is 2. And once again, we have to go to the x-axis. And so we'll put 2, and with the dot, we have an equal to bar. So then, once we've done our domain, now we need to look at the range. Now with the range, that's the y's. So we're going to be taking a look at the y-axis. Well, we need to look at the lowest point. We look right here, but that's not the lowest point in this graph. This would be the lowest point. And then we don't want to look at the x-axis, we want to look at the y-axis. So whenever you're looking at the range, we want to make sure that we know which axis we're looking at. So for the lowest that goes on the y-axis, this would be -6, and it's filled, the circle is filled in, so we put an equal to bar. And then the highest we go, once again, it's not about the dots necessarily, it's about the highest point on the graph. Well, that would be right here. And once again, we go to the y-axis. So that would be +3. And the only time we don't put an equal to bar is if there's an open circle. So the line would include an equal to bar. And so this says my domain goes from -6 to positive 2, and my range goes from negative 6 to positive 3. Alright, let's take a look. Sometimes we have arrows on our graphs. So if we have an arrow going in both directions, then we consider this all real numbers. Well, you got to remember, you can't just say, well, I've got 2 arrows. You have to look at the top and the bottom, and then left and right. You have to do that separately, and you'll see why that's important here in just a second. But the domain has an arrow furthest to the left, furthest to the right, so that's all real numbers. The range has an arrow furthest down and the furthest up, so that's all real numbers. So both the domain and the range would be all real numbers. Now, this one only has an arrow on one side. So if I only have an arrow on one side, then whenever I do my domain, whatever side the arrow's on, I just don't do that side. So I have a furthest to the left. It's an open circle at negative 4. So I'm looking at the x-axis right here. So negative 4, it's an open circle, so I do not put an equal to bar. Then on the right-hand side, I have an arrow. So I don't need to do this side right there. Now, whenever we write inequalities, if we've only got one inequality symbol, we like for our x to be on the left. So I'm going to flip this, and when I do, the symbol, the alligator that we like to call it, is eating the x. So when I flip it, it still has to be eating the x. So we'll flip this entire thing. So this is my domain. Now the range, we're going to be looking at the y-axis. So that's how low it goes, okay, right here, which is negative 1. And then how high it goes, well, I have an arrow there. So once again, I only do one side. So I had the low side was negative 1, and it was an open circle, so I do not put anything. And then the high as it goes had an arrow, so I don't need to do that side. And then once again, I want my y to be on the left, and the alligator's eating it, so we will flip this and say y is greater than negative 1. Alright, we'll do just a few questions. Okay, so here's kind of what I was talking about. We start off with domain. It's easy to look at this and think that everything's all real numbers, but take this one thing at a time. Furthest to the left, I have an arrow. Furthest to the right, I have an arrow. So we're not going to have this, we're going to have all real numbers. Okay. Now, once again, it's easy to think that range is going to be all real numbers, but while I do have arrows down low, I do not have an arrow up high. And so I need to do the side that's up high, which would be the right-hand side. And so the high as it goes would be negative 2, and it's a part of the line, so we include an equal to bar. But I do not need to do how low it goes because that has arrows. So while my domain is all real numbers, the range is y is less than or equal to negative 2. So don't always assume that just because there's 2 arrows that both of these are all real numbers. Okay, this is discrete data, so all we have to do is to list it. So we have 1, 2, 3, 4. And then for my y's, they're all negative 3. So I just need to list that once. And that's my domain, or my range. Okay, taking a look at another one. Okay, so this is where it gets hard to do discrete. Dots are discrete, and so all I need to do is to list it. But when I list this, you have to go to each dot and then look at the x-axis. So this dot right here is already on the x-axis at negative 3. And then this dot, we've got to go down and take a look, and you can see that's at negative 1. And then a lot of people will want to call this 4.5, but that's the y-axis. We've got to go all the way down, and this is 0. So anytime that you're looking at domain, you've got to go to the x-axis to get your answers. Alright, so that is my domain. And then for my range, now we're going to go look at everything and go to the y-axis. So this is the lowest dot, which goes to 0. The next lowest would be this one, which goes to 4. And then this one's on 4.5, so that is the y-axis, so now we want that 4.5. And then 6 and 7. And every time I'm going to the y-axis because I'm doing range. Okay, this is continuous, and there are no arrows, so I know I'm going to have both of these. So domain first, I'm looking how far to the left does this go. Right there at -3, and the circle's filled in, so I'll include an equal to bar. This is as far right as we go, right here, so that would be at +3. But this one has an open circle, so I do not put an equal to bar. So my domain is -3 is less than or equal to x is less than 3. Okay, so when we switch over to range, now my arrows are going to go to the y-axis. And I see a lot of kids doing this right here, but you can clearly see that's lower than this point right here. We've got to go to the lowest spot on the graph, not the lowest point. So the lowest spot on the graph is going to be right here, which would be -2. And it's a part of the graph, so we include the equal to bar. The highest point on the graph is right there, at 9. And it's an open circle, so we do not need an equal to bar. And we're going to do 2 more, just real quick. This is going to be an easy one because furthest left, furthest right, this is all real numbers. Got my arrows. And then furthest down and furthest up, I have arrows. So this is all real numbers. So here's another one that has arrows, but even though my furthest left and furthest right have arrows, which makes this all real numbers, I do not have arrows going down. And so I have arrows up on the top. I do not have arrows down here. So my arrows down low that would go on the left-hand side, this is at -3 right here. So -3 is part of the line. And then I'd like for my y to be on the other side. So we will flip this alligator eating the y. It's greater than or equal to -3. Alright, well, I hope this helps.